All right, so in 6-8, we're gonna be integrating composite functions. And sometimes these can get tricky, so what we do is called u substitution or just substitution. Um, and you substitute in this variable u because it helps you integrate it more easily. So I was reading through this, and I did this last year, and this paragraph kind of makes it more confusing, so I'm just gonna leave it out because there's like a pattern recognition way. But it's actually more confusing than just learning straight substitution. So let's say you have to integrate something like this, x times 2x minus 1 cubed. So hopefully you can tell that this is a composite function, right? Because remember, a composite function is like f of g of x. So what's the inner function here, right? What is our g of x? Well, our inner function is this 2x minus 1, okay? And our outer function is all of this outside of that, right? So when you are, when you get to a composite function, right? So this is our inner function here. And you need to integrate it. You need to substitute in a variable for the inner function. So in this case, we are going to use u. Well, u is what you always see. Done. So let's just come down here. These are kind of your steps, 1, 2, 3, 4. So 1 says let u be the inner function. So in our case, u is going to be this inner function, which is 2x minus 1. Okay? Now, we need to find du. So what's the derivative of that? The derivative of du is just 2 dx, right? Derivative of x dx. Nothing with a constant. Okay. Now the second part of this is to... So sometimes you can do this, sometimes you don't have to. I'll do it this way. So you can rearrange it for dx. So we can also rewrite this as dx equals du over 2. Okay? So why? Because now when we set up our new integral, it might be helpful to have one of these. So let's see what happens. So now it says find an expression for x in terms of u. So step 3 is to take our u equals 2x minus 1 and to rearrange it for x. So you would end up with u plus 1 equals 2x, which would be u plus 1 over 2 equals x. So now we can rewrite the entire integrand as a polynomial or a polynomial type of function in terms of u. Then we can differentiate. So what does that mean? So we started off with this, right? So now let's substitute in. We know that this is u cubed, right? 2x minus 1 is u cubed because 2x minus 1 is u. And then what else? We know that dx, we solved it here, is du over 2, right? Using that. Well, what about this x? Well, we rearranged it for x, so we can plug in this for x times u plus 1 over 2, right? So that is the entire integral rewritten in terms of u. So now let's just simplify. What do we have here? We have, this is 1/2 u plus 1, right? Then we have u cubed. And we have another 1/2 here, so I can actually, do I have an eraser? I'm going to take that 1/2 out and make this 1/4. And then we have du. All right, now I know I can take the 1/4 out, and I have, let's just distribute that. I have u to the 4th plus u cubed du. All right, now I know I can integrate that. I have 1/4 times u to the 5th over 5 plus u to the 4th over 4 plus we have our constant c. All right, so now what does that become? That becomes 1/20th times u to the 5th plus 1/16th times u to the 4th, all plus c. Now to get our final solution, we can plug the expression back in for u, right? So it end up with 1/20th 2x minus 1 to the 5th plus 1/16 times 2x minus 1 to the fourth, all plus c. All right, so that is that way. So there's another way to do this that I want to show you. Let me get a blank piece of paper. So this is the easiest, straightforward way. You solve everything in terms of u, or you solve it in terms of solving for dx and x and plugging those back in. Sometimes you can also notice some patterns. So I'm trying to quickly do this in my head and see if that works. So here when we said u is 2x minus 1, and du therefore would be what? 2dx. So I'm trying to compare that. Watch, I'm probably going to say, oh, this doesn't work for this one. Just give me a second. Let me see if it does. You know, I don't work so well with doing things in my head. In my head, I have to work it out. So one thing I notice, 2dx. Yeah, so this one doesn't work because there's an x here. Sometimes when you work this out, and maybe I'll do one where there's an example of that. Sometimes when you work this out, you'll notice that your u and your du can be substituted in perfectly, and you don't have to do all this solving and rearranging. I think I have one in my notebook that I'll do. Yeah, I'll do that one next. Ignore my side note. Let's try one more. Okay, so we have 2x plus 1 over root x plus 4 dx. Okay, so I'm going to rewrite this as a product of 2x plus 1 and then x plus 4 to the minus 1/2 and then dx. Okay, so what am I going to do here? So first of all, your thought is like, this is complicated. What's my inner function? What's my outer function? So sometimes you have to play around with them. Sometimes you'll pick out a u and it won't be helpful. So for example, I'm going to make u equal to x plus 4. Sometimes you'll try this and you'll end up with an even more complicated integral that doesn't work out. So then you go back and be like, all right, let's make u 2x plus 1, for example. Right? But right now, x plus 4 to the negative 1/2 looks like it's more complicated. So then what would du be? Du would be 1 dx, or just dx, right? Okay, I don't need to rearrange and solve it for dx. It's already solved. So now let's solve this equation for x. U minus 4 equals x. So when we rewrite our integral in terms of u, we have what? 2, well, what's x? X is u minus 4. All of this is plus 1. And now here we have x plus 4 to the negative 1/2. So that's going to be x plus 4 is now u. So that's going to be u to the minus 1/2. And what's dx? Dx is du. Writing the whole thing in terms of u. So now what does this become? This becomes 2u minus 8 plus 1 all times u to the minus 1/2 du. This becomes 2u minus 7 all times u to the minus 1/2 du. Okay, so let's distribute this minus 1/2 in. So that becomes 2 u to the 1/2 minus 7u to the minus 1/2 du. Now we can integrate this, right? Because we could break it up. So this becomes 2 u to the 3/2 over 3/2 minus 7 u to the 1/2 over 1/2 plus c. So now when we solve this, I'm just going to write over here, we're going to end up with what? 4/3 u to the 3/2 minus 14 u to the 1/2 plus c. So now all I have to do is plug in what u equals, which is x plus 4. So you end up with 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus c. Okay. All right. Now this last one, it says to use a graphing calculator. So let me get my ready. says you try. So if you want to pause, you can pause, try to solve it on your own, come back and see if it matches what I have here, okay? So find the value of integral from 0 to 4, x times root 2x plus 1 dx. And then we're going to check it using a calculator. Okay, so right away, I am thinking this is the inner function, so I'm going to set u equal to 2x plus 1. That means du equals 2 dx. Okay, so now let's rearrange this. This means that x equals what? U minus 1 over 2. And then that du equals what? I'm sorry, dx equals du over 2. Yeah. Okay, so let's rewrite it. So right away, when I'm rewriting this, I can say that x is u minus 1 over 2. And then we have it's being multiplied by, I'm going to write it as u to the 1/2 instead of the square root. And then dx is equal to du over 2. Right? So this is exactly like, it's similar to the first problem, except we have a different power on the 2x plus 1. So here, now you're tempted to go write your bounds in, and you're going to write 0 to 4. But we can't write 0 to 4. Here's why. 0 to 4 meant when x is going from 0 to 4. But we've changed our variable to u. So now we have to figure out the bounds in terms of u. So we know that u equals 2x plus 1. So what happens when x is 0? That means u is 2 times 0 plus 1, which is 1. So that's our lower bound. And now what happens when x is 4? U would be 2 times 4 plus 1, which is 9. So now 9 is our upper bound. Okay, so when you are rewriting your integral in terms of u, if you're going to put the bounds on it, you need to change the bounds based on u. The other thing you could do is just make this an indefinite integral and solve for it, and then plug back in the bounds when you get it in terms of x. But that's how you would do that if you want to do that first. Okay, so now when we solve this, I can pull out this 1/4, right? And then I have from 1 to 9 of u minus 1 times u to the 1/2 du, which that equals 1/4 times 1 to the 9 of, this becomes u to the 3/2 minus u to the 1/2 du. So that equals 1/4. And now we can just solve this like this. If I integrate that, that's u to the 5/2 over 5/2 minus u to the 3/2 over 3/2. And then we are evaluating that from 1 to 9. So that becomes 1/4 times 2/5 times, now I'm just going to plug in that 9. Nine to the 5/2 minus 2/3 times 9 to the 3/2. Now let's plug in 2/5. Or let's plug in 1, sorry. So when we plug all that in, you can do this in your calculator, right? This is like you check the result using the graphing calculator. You end up with about 19.8675. So you can plug that in to check. So really the only new learning for this last example is changing the bounds in terms of u. All right, I might record one more example after this, but I'll see you next time.